You are listening to Crafting the Responsive Web, modern CSS layout with Flexbox, Grid, and beyond. Like and subscribe to keep up to date on our latest audiobooks. Crafting the Responsive Web, modern CSS layout with Flexbox, Grid, and beyond. 1. Introduction: the evolution of web layout. Welcome to the captivating world of modern web layout, a realm that has undergone a profound transformation in recent years. If you've ever spent time online, you've witnessed this evolution, perhaps without even realizing it. From static, blocky pages to dynamic, flowing designs that adapt to any screen, the way websites are structured has changed dramatically. This book is your guide to understanding and mastering the powerful tools that have made this revolution possible. Flexbox, Grid, and the exciting techniques that extend their capabilities. To truly appreciate where we are today, it's essential to glance back at where web layout began. Imagine the early days of the internet, a time before everyone carried powerful mini-computers in their pockets. Websites were primarily text documents with a few images, designed for large, fixed desktop monitors. There were no sophisticated layout tools. Designers, working with a limited palette, often resorted to ingenious, if somewhat unconventional, methods to arrange their content. One of the most common approaches involved using the HTML table element, originally intended for displaying tabular data, like spreadsheets. Need a header, a navigation sidebar, a main content area, and a footer. You'd create a giant, invisible table and place each section into a separate cell. While effective in some ways, this was like building a house with only a hammer and nails, and those nails were really meant for something else entirely. It led to inflexible designs that broke easily when content changed, and it meant mixing content structure with visual presentation, a practice modern web developers try to avoid. As the internet grew, so did the need for more complex designs. Enter CSS, or cascading style sheets, a new language specifically designed to control the presentation of web content. CSS was a game changer, but its early versions didn't offer dedicated layout modules. So, developers gravitated towards another clever workaround: the float property. The float property was originally intended for wrapping text around images, much like how a picture might float in a newspaper column. But enterprising designers quickly discovered they could apply float left or float right to larger elements like div elements to create multi-column layouts. If you wanted a main content area with a sidebar, you'd float both of them, and voila, you had two columns. While an improvement over tables, float layouts came with their own set of frustrations. Imagine trying to precisely align three distinct elements, say, a logo, a navigation menu, and a social media icon, all horizontally across the top of a page. With floats, this was a constant challenge. Elements would sometimes overlap unexpectedly, or stubbornly refuse to align vertically. The problem of perfectly centering anything, whether it was an image or a block of text, was notoriously difficult, often requiring calculation and clever hacks that felt more like magic tricks than reliable engineering. And if one of your floated columns ended up being shorter than the other, the layout beneath it might awkwardly try to wrap around the taller column, creating unpredictable visual breaks. Developers spent countless hours tackling something called clearing floats, a necessary evil to prevent elements from straying where they shouldn't. Then came the smartphone. The introduction of mobile devices fundamentally shattered the assumption of a single, fixed screen size. Suddenly, websites had to look good not just on a large desktop monitor, but also on a medium-sized tablet held in portrait or landscape orientation, and a tiny phone screen, also potentially held either vertically or horizontally. The old float and table-based layouts, rigid and unforgiving, simply couldn't keep up. They either broke completely, forced users into endless horizontal scrolling, or required multiple, separate versions of a website, leading to maintenance nightmares. This massive shift ushered in the era of responsive web design. The core idea behind responsive design is elegant. A single website codebase should adapt gracefully to any screen size and device. Whether you're browsing on a monstrous desktop monitor, a mid-sized tablet, or the smallest phone, the website should intelligently rearrange and resize its content to provide an optimal viewing experience. This wasn't about shrinking everything down. It was about truly optimizing the experience. To achieve this, web designers adopted a mobile-first philosophy. Instead of designing for the largest screen and then trying to cram it down, they started by designing for the smallest screens first, ensuring essential content and functionality were accessible. Then, they progressively enhanced the layout for larger screens, adding more complexity, columns, and visual richness where space allowed. The primary tool for this adaptation became media queries, which allow you to apply different CSS rules based on characteristics like screen width, height, or even resolution. For example, you could tell your browser, if the screen is less than 768 pixels wide, present this content in a single column. If it's wider, arrange it in 2 columns. Despite these innovations, a fundamental problem remained. CSS still lacked truly intuitive tools for handling the complex alignment and distribution of elements within those flexible layouts. Imagine a time when, for years, web developers dreamed of what was called the Holy Grail layout. A page with a header, a 3-column main section, a sidebar on the left, primary content in the middle, and a sidebar on the right, and a sticky footer that always stayed at the bottom of the browser window, even if the content above it was short. Achieving this with floats was a painstaking, often fragile endeavor. But then, the world saw its true heroes, Flexbox and Grid. These aren't just incremental improvements, they represent a monumental leap forward in web design. They are purpose-built layout systems, designed from the ground up to solve the very problems that plagued designers for so long. Flexbox, short for the Flexible Box module, is specifically designed for one-dimensional layouts. Think of it as a precise tool for aligning and distributing items along a single line, either horizontally or vertically. It's perfect for arranging elements within a header, a navigation bar, or a small collection of items. Finally, with Flexbox, perfectly centering an element horizontally and vertically became a single line of CSS, not a dark art. CSS Grid, on the other hand, is the architect's blueprint for the entire page. It's a 2-dimensional layout system, allowing you to control both rows and columns simultaneously. With Grid, you can create intricate, precise page structures, defining specific areas for your main content, sidebars, headers, and footers, and then placing elements into those areas with incredible control. It's the solution to that Holy Grail layout and so much more. The beauty of Flexbox and Grid is that they are not competing, they are complementary. Grid is often used for the macro layout of an entire page or a large section, while Flexbox shines when used for the micro layout of content within those grid areas. As you'll discover in this book, combining their powers unlocks unprecedented flexibility and control over your designs. In the chapters that follow, we will embark on a journey, starting with the fundamental principles that underpin all modern CSS layouts. We'll then dive deep into Flexbox, exploring its properties and seeing it in action. After that, we'll do the same for CSS Grid, learning how to build robust, multi-dimensional structures. Crucially, we'll then explore how to harmonize these two powerful systems to create responsive, adaptable designs that truly shine on any device. Finally, we'll look beyond the basics to cutting-edge CSS features, discuss real-world applications, best practices, and peek into the exciting future of web layout. By the end of this book, you will have a comprehensive understanding of how to craft beautiful, functional, and user-friendly web layouts that stand the test of time and device diversity. Get ready to stop wrestling with your designs and start truly designing them with confidence and precision. 2 foundations of modern CSS, core principles. Before we dive into the exciting world of Flexbox and Grid, it's essential to lay a solid foundation. Just as a skillful architect needs to understand building materials and structural mechanics before designing a skyscraper, a modern web designer must grasp the core principles that govern how elements behave on a web page. These principles are not new, but understanding them in the context of modern CSS is crucial for building robust and responsive layouts. Our journey begins with the indispensable CSS box model. Imagine every single element on a web page, whether it's a heading, a paragraph, an image, or a button, as a rectangular box. This box model describes how the space around and within that box is calculated and rendered by the browser. It has 4 main components, working from the inside out. Content. This is the actual substance of your element, your text, images, videos, or other media. The size you define for an element, say, its width and height, traditionally referred to the content area. Padding. This is the space between the content and the element's border. Think of it as the soft cushioning inside a gift box, protecting the present, your content, from the edges of the box itself. Padding adds to the overall size of the element. Border. This is the line that goes around the padding and content. It's the sturdy cardboard of your gift box. Borders also add to the element's total dimensions. Margin. This is the space outside the border. It's the invisible buffer that separates your gift box from other gift boxes on a shelf. Margins define the empty space between elements. Historically, the way browsers calculated an element's total size could be a bit confusing. If you set an element's width to 100 pixels, and then added 10 pixels of padding on each side and a 1-pixel border, the element would end up being 122 pixels wide in total. 100 content plus 10 left padding plus 10 right padding plus 1 left border plus 1 right border. This often led to frustrating situations where elements wouldn't fit where you expected them to. Thankfully, modern CSS offers a simple yet incredibly powerful solution: box sizing, border box. When you apply this property, the width and height you specify for an element include its padding and border. So, using our previous example, if you set an element's width to 100 pixels and then add padding and a border, the content area will shrink to accommodate them, but the total width of the element will remain precisely 100 pixels. This is like a gift box where the overall dimensions are fixed, and the amount of padding inside adjusts rather than adding to the outside. This small change brings immense predictability and simplifies layout calculations, making it the de facto standard in modern web development. Next, let's talk about CSS units, the measurements we use to define sizes, spacing, and positions. They fall into 2 broad categories: absolute units. These are fixed, immutable measurements. The most common is the pixel, px. A pixel always represents a single point on a screen. While convenient for precise, unchanging elements, absolute units offer little flexibility. If you build your entire design using fixed pixel values, it won't adapt well to different screen sizes or user preferences. Relative units. These are the backbone of responsive design, as their values adapt based on context or a specific reference point. Percentage, %, often used for widths and heights, percentages are relative to the size of the parent element. 50% width means half the width of my parent. This unit is relative to the font size of the parent element. If a parent element has a font size of 16 pixels, then 1 inside that element would be 16 pixels. This can lead to a compounding effect, where nested elements with units can become unexpectedly large or small. It's like telling someone to move 2 steps from where you are standing now. Root M. This is where things get truly powerful for scalability. Rem is relative to the font size of the root HTML element, the very top-level HTML tag. This means its value is consistent across your entire document, regardless of where an element is nested. If you set the root font size to 16 pixels, then 1 rem is always 16 pixels everywhere else. This is like telling someone to move 2 steps from the starting line. This consistency makes rem ideal for setting scalable font sizes and even spacing, as users can simply adjust their browser's base font size, and your entire website's typography and layout will scale up or down proportionally, a huge win for accessibility. Viewport units, VW, VH, Vmin, Vmax. These units are relative to the size of the user's viewport, which is the visible area of the browser window. VW, viewport width. 1 VW is 1% of the viewport's width. VH, viewport height. 1 VH is 1% of the viewport's height. Vmin, 1% of the smaller dimension, either width or height of the viewport. Vmax, 1% of the larger dimension of the viewport. These units are fantastic for creating truly fluid designs, allowing elements to grow or shrink perfectly with the browser window. For example, a heading set to 5 VW will always be 5% of the screen's width, scaling beautifully whether you're viewing it on a phone or an extra-wide desktop monitor. Understanding how elements naturally position themselves is also key. This is known as the document flow. By default, HTML elements arrange themselves in a predictable order. Block-level elements, like paragraphs, headings, or div elements, stack vertically, each taking up the full available width and starting on a new line. Inline elements, like span or for links, flow horizontally within the text, only taking up as much space as their content requires. Flexbox and Grid offer powerful ways to manipulate and override this default flow, allowing us to precisely control arrangement without resorting to the old tricks. Finally, at the heart of modern web development lies responsive design. As discussed in the previous chapter, it's the art of crafting web experiences that adapt seamlessly to various screen sizes and device types. Two foundational concepts drive this: mobile-first strategy. This is more than just a technique. It's a design philosophy. Instead of designing for large desktop screens and then trying to gracefully shrink content for smaller devices, you start by designing and building for the smallest screen first. This forces you to prioritize content, simplify interfaces, and deliver the fastest performance to users on less powerful devices or slower connections. Once the mobile experience is solid, you then progressively enhance the design by adding more complex layouts, features, and richer visuals for larger screens and more capable devices. For instance, when designing a restaurant's website, you'd ensure the menu and contact information are quickly accessible and legible on a phone. Then, for a tablet, you might add a 2-column layout with a photo gallery. And for a large desktop monitor, you could integrate a full-screen background video and detailed reservations form. Media queries. These are the primary technical tools that make responsive design work. Think of a media query as a set of instructions that the browser only follows if certain conditions are met. It acts like a gatekeeper for your CSS. For example, you can tell your style sheet, apply these specific styles only if the screen is wider than 768 pixels. This allows you to completely alter layouts, change font sizes, hide show elements, and much more based on the characteristics of the user's device. The most common conditions for media queries are based on min width and max width. At media screen and min width, 768px. This means if the screen is for a display and its width is at least 768 pixels, then apply the following styles. This is perfect for mobile-first design, where you define your base styles for small screens and then layer on styles for progressively larger screens. At media screen and max width, 600px. This means if the screen is for a display and its width is at most 600 pixels, then apply the following styles. This is often used for desktop-first approaches or to apply specific adjustments for very small screens. You can also combine conditions, like min width and orientation, e.g., landscape or portrait, to cater to even more specific scenarios. An important concept related to media queries is breakpoints. These are the specific points at which your layout changes. It's crucial to understand that breakpoints shouldn't be tied to specific device sizes, like iPhone breakpoint or iPad breakpoint. Instead, they should be content-driven. This means you introduce a breakpoint wherever your content starts to look awkward or broken as the screen size changes. If your main navigation bar looks cramped at 800 pixels, that's a good spot for a breakpoint to perhaps stack the menu items vertically. By grasping these foundational concepts, the predictable box model, the power of relative units, the nuances of document flow, and the adaptability of responsive design with media queries and a mobile-first approach, you are now armed with the essential knowledge to confidently tackle the revolutionary layout systems of Flexbox and Grid. They will allow you to describe complex arrangements with unprecedented simplicity and control, ensuring your web creations look and feel native on any device the modern world throws their way. 3. Flexbox Unleashed. One-dimensional layouts. Now that we've established our foundational concepts, it's time to introduce one of the most transformative tools in modern CSS, Flexbox. Often referred to as the Flexible Box Module, Flexbox is a one-dimensional layout system. What does one-dimensional mean in this context? It means Flexbox is designed to arrange items either in a single row or in a single column. This might sound simple, but it's precisely this focused capability that makes Flexbox an incredibly powerful and versatile tool for aligning, distributing, and ordering content within components and sections of your web page. Before Flexbox, something as seemingly straightforward as vertically centering an element or distributing a set of items evenly across a horizontal space was a notorious challenge, often requiring complex calculations or fragile CSS hacks. Flexbox makes these tasks, and many others, elegantly simple. The core idea behind Flexbox is the relationship between two types of elements. The Flex container. This is the parent element where you apply display, flex, or display, inline flex. Once an element becomes a Flex container, its direct children automatically become Flex items. The Flex items, these are the direct children of the Flex container. They are the individual elements whose layout and alignment you will control using Flexbox properties applied to either the container or the items themselves. Imagine a group of dancers on a stage. The stage itself is your Flex container, and each dancer is a Flex item. Flexbox gives you, the director, a set of powerful controls to arrange these dancers. The main axis and the cross axis. This is the most crucial concept to grasp in Flexbox. Every Flex container has two axes. The main axis. This is the primary axis along which your Flex items are laid out. By default, with Flex direction, row, the main axis runs horizontally from left to right. If you change Flex direction to column, the main axis runs vertically from top to bottom. The cross axis. This axis is always perpendicular to the main axis. So, if your main axis is horizontal, your cross axis is vertical, and vice versa. Understanding these axes is fundamental because different Flexbox properties align items along either the main axis or the cross axis. Let's explore the key properties you'll apply to the Flex container. Flex direction. This property defines the main axis and the direction Flex items are placed in the container. Row default. Items flow horizontally, left to right, or right to left in right to left languages. Row reverse. Items flow horizontally, right to left. Column. Items flow vertically, top to bottom. Column reverse. Items flow vertically, bottom to top. Analogy. This is the very first instruction you give your dancers. Line up in a row, or line up in a column. Justify content. This property aligns Flex items along the main axis. It controls how space is distributed among and around the items when there's extra space in the container or when items are not allowed to grow. Flex start default for row, items are packed towards the start of the main axis. Flex end, items are packed towards the end of the main axis. Center, items are centered along the main axis. Space between. The first item is at the start, the last is at the end, and the remaining space is distributed evenly between the items. Space around. Items have equal space around them. The space between adjacent items is twice the space at the ends. Space evenly. Items have equal space between them and at the ends. Analogy. Once your dancers are in a row, justify content is how you spread them out along the length of the stage. All to the left. Center yourselves. Spread out evenly from wall to wall. Align items. This property aligns Flex items along the cross-axis. It controls how items are aligned perpendicularly to the direction of flow. Stretch default. Items stretch to fill the container along the cross-axis if they don't have a specific height-width defined. Flex start. Items align to the start of the cross-axis. Flex end. Items align to the end of the cross-axis. Center. Items are centered along the cross-axis. Baseline. Items align based on their baselines, useful for text elements to ensure consistent typography. Analogy. With your dancers lined up, align items is how they line up their vertical positions. Everyone stand tall. Everyone kneel down. All shoulders at the same height. Flex wrap. This property controls whether Flex items are forced onto a single line or can wrap onto multiple lines. No wrap, default. All Flex items will try to fit onto one line, potentially causing overflow. Wrap. Items will wrap onto multiple lines from top to bottom or left to right if Flex direction is column. Wrap reverse. Items will wrap onto multiple lines from bottom to top. Analogy. If your stage isn't wide enough for all the dancers in a single row, FlexWrap decides if they squeeze together, no wrap, or start a new row, wrap. Align content. This property aligns multiple lines of wrapped flex items along the cross-axis. It only has an effect when FlexWrap is set to wrap or wrap reverse, and there is extra space in the cross-axis direction. Values are similar to justify content. Flex start, flex end, center, space between, space around, stretch, default. Analogy: if you have several rows of dancers, because they wrapped, align content is how you distribute those rows of dancers vertically on the stage. All rows to the top. Center all the rows. Now, let's look at the properties you can apply to individual flex items. Flex grow. This property specifies how much an item will grow relative to the rest of the flex items in the container if there's extra available space along the main axis. A value of 1 means it will take up 1 unit of available space. If 2 items have flex grow, 1, and 1 has flex grow, 2, the latter will take up twice as much of the available space. Analogy: imagine a buffet line. Flex grow is like how much extra food a person can take if there's food left over. Flex shrink. This property specifies how much an item will shrink relative to the rest of the flex items if there isn't enough space in the container along the main axis. A value of 1 means it will shrink proportionally. A value of 0 means it won't shrink at all, potentially causing overflow. Analogy: if the buffet runs low, flex shrink is how much a person must reduce their portion. Flex basis. This property defines the initial size of a flex item before any growing or shrinking takes place. This can be a length value, like 200 px, or a percentage, 25%. If not specified, it defaults to auto, which usually means the item's content size. Analogy: this is the initial size of a serving on your buffet plate before any adjustments for abundance or scarcity. Flex, shorthand. This is a shorthand property that combines flex grow, flex shrink, and flex basis. For example, flex 1 auto sets growth, shrink, and initial basis. Flex 1 is a common shorthand for flex 0%, meaning it grows and shrinks from an initial size of 0. Order. This property controls the visual order of flex items within the container. By default, all items have order 0. Items with lower order values appear first. Use this with extreme caution. Changing the visual order with order does not change the underlying source order of your HTML. This can be confusing for users who rely on screen readers or keyboard navigation, as their experience will follow the source order, not the visual one. It's generally best to keep source order and visual order aligned for accessibility. Analogy: this is like telling one dancer to stand at the front of the line, even though they were initially at the back. Align self. This property allows an individual flex item to override the align items setting defined on the flex container for itself. For example, if align items is center for the container, but you want one specific item to align to flex start, you'd apply align self. Flex start to that item. Analogy: all dancers are kneeling, align items, flex end, but one dancer decides to stand tall, align self, flex start. Let's imagine a simple scenario to solidify these concepts. You have a series of navigation links for a website, and you want them to appear horizontally in the header, distributed evenly, and perfectly centered vertically within the header's height. You would wrap your navigation links, perhaps a tags inside a ol or nav element in a parent container, let's say a nav tag. You apply display, flex, to this nav element. It becomes the flex container. Its direct children, your list items or links, become flex items. To make them appear horizontally, flex direction is row by default, so we don't need to explicitly set it, though you can for clarity. To distribute them evenly across the header, you might use justify content, space around. This tells Flexbox to put equal space around each link. To make sure they are perfectly centered vertically within the navigation area, you would use align items. Center. Suddenly, with just a few lines of CSS, you have a responsive, perfectly aligned navigation bar, a task that once required a significant amount of effort and often brittle code. Flexbox has revolutionized how we approach one-dimensional layouts. It provides intuitive, powerful controls for aligning, spacing, and ordering elements within a single row or column. In the next chapter, we'll put these properties into action, exploring common design patterns and practical applications where Flexbox truly shines. 4. Flexbox in action. Practical Flex layouts. In the previous chapter, we dissected the core concepts and properties of Flexbox. Now, it's time to move from theory to application. Flexbox excels at solving a wide array of common user interface challenges that, before its advent, were often tedious and required awkward workarounds. By understanding how to combine Flexbox properties, you can create elegant, responsive components with remarkable ease. Let's explore some practical, real-world examples where Flexbox truly shines. Navigation menus. One of the most frequent uses for Flexbox is building responsive navigation menus. Consider a typical website header that needs to display a logo on one side and a series of navigation links on the other. You might have a div or header element as your Flex container. Inside it, your logo would be one Flex item, and your navigation UL, which you can also make a Flex container for its list items, would be another. By applying display, Flex, justify content, space between. To the main header, your logo will automatically be pushed to the far left, and your navigation links to the far right, with all available space distributed between them. Within the navigation UL setting display, Flex would arrange its lead children horizontally. You could then use justify content, space around, or gap, which we'll cover more in a later chapter, to beautifully space out your individual menu items. For responsiveness, if you have a traditional horizontal menu that you want to stack vertically on smaller screens, you'd add a media query that changes the flex direction of your navigation container from row to column, and adjust align items to stretch or flex start to fill the available width. This transforms a horizontal menu into a neatly stacked, full-width mobile menu with minimal effort. Card layouts. Imagine an e-commerce category page displaying a grid of product cards, or a blog showcasing a series of article previews. Each card typically contains an image, a title, a price or summary, and perhaps an Add to Cart button. The container holding all these cards can be made a Flex container with display. Flex. Crucially, you would add Flex wrap. This tells Flexbox that if there isn't enough horizontal space to fit all cards on one line, they should wrap onto the next line. This is the magic that creates your responsive card grid. To ensure all cards have a consistent look, even if their internal content varies slightly in height, e.g., one product title is 2 lines, another is 1, Flexbox's default align items. Stretch. On the container, we'll make all cards stretch to the height of the tallest card in that row. This creates a visually clean, uniform appearance. Inside each individual product card, Flexbox can be used again. You could make the card itself a Flex container with Flex direction. Column. This would neatly stack the image, title, and price. You might then use justify content, space between, to push the Add to Cart button to the bottom of the card, ensuring it's always flush with the card's edge, regardless of how much content is above it. This demonstrates the power of nesting Flex containers. A Flex item can itself be a Flex container. Centering elements. This was once the bane of web developers' existence. With Flexbox, it's almost trivial. If you want to perfectly center an element, both horizontally and vertically, within its parent container, make the parent the Flex container. Display, Flex, align along the main axis, horizontal by default. Justify content, center, align along the cross-axis, vertical by default. Align items, center. Just 3 simple rules, and your element will snap perfectly to the dead center of its container. No more confusing negative margins or positioning tricks. This is incredibly useful for modal windows, image galleries, or any single component that needs to stand out. Media objects. A common design pattern is the media object, where an image or icon sits side by side with a block of text, like a comment, a profile header, or a list item with a thumbnail. This pattern needs to gracefully handle responsiveness, often stacking the text below the image on small screens. Make the container for the image and text block a Flex container. Display, Flex. The image element and the text div or P are its Flex items. By default, they will appear horizontally. You might add align items, Flex Start, to align the top of the text with the top of the image. For a mobile screen, a media query can change flex direction, column, on the container. This instantly stacks the image on top of the text. You might also add align items, center. In this mobile context, to horizontally center both the image and the text block within their new vertical arrangement. Form element alignment. Flexbox can greatly simplify the layout of forms, ensuring labels, input fields, and buttons align neatly. For an inline search bar with an input field and a button next to it, make their parent display Flex. This will align them side by side. You can then use FlexGrow on the input field to make it expand and fill available space, while the button stays a fixed size. For a contact form with labels and inputs, you can make each form row a flex container. This gives you control over whether labels appear above inputs or to their side, and how they align. For example, if labels are on the side, you can align items, center, to vertically center the label with its input field. Utilities and layouts. Flexbox can also be used for broader page sections. Consider making your entire body or main layout container a flex container with flex direction, column, by applying min height 100 VH, 100% of the viewport height to this container, and then setting flex 1. On your main content area, between your header and footer, you can easily create a sticky footer. The main content area will FlexGrow to push the footer always to the bottom of the viewport, even if the content is sparse. This resolves another classic layout challenge. Flexbox has simplified countless common layout problems. It provides a highly intuitive way to arrange items in a single dimension, offering precise control over spacing, alignment, and ordering. Its ability to be nested makes it incredibly powerful for building reusable components that adapt intelligently to different contexts. As we move on to CSS Grid, remember that Flexbox isn't replaced, but rather complemented by it. The combination of these two powerful systems truly unlocks the potential for modern web design. 5. CSS Grid, the two-dimensional revolution. If Flexbox is the master of one-dimensional alignment, arranging items neatly along a single row or column, then CSS Grid is the grand architect, the urban planner behind your entire web page. CSS Grid, often simply called Grid, is a two-dimensional layout system. This means it allows you to control both rows and columns simultaneously, giving you unprecedented power to define the underlying structure of your web designs, from page-wide layouts to complex components. Think of it like an architect working on a blueprint for a house. The architect first defines the rooms, hallways, and load-bearing walls. Only then are the furniture and decor placed precisely within these defined spaces. Grid allows you to do exactly this for your web page. You define a precise grid of rows and columns, and then you tell your content elements where to go within that grid. Just like with Flexbox, Grid operates on a container item relationship. The grid container. This is the parent element to which you apply display, grid, or display, inline grid. This declaration immediately turns its direct children into grid items. The grid items, these are the direct children of the grid container. They are the individual elements that you will place and arrange within the grid structure you define. Before diving into properties, let's understand the fundamental components of a grid system. Grid lines. These are the horizontal and vertical dividing lines that form the grid. If you have 3 columns, you'll have 4 vertical grid lines, one before the first column, one between each column, and one after the last. Similarly, n rows will have n plus 1 horizontal grid lines. Grid tracks. These are the spaces between the grid lines. They are your actual rows and columns. When you define your grid using properties like grid template columns, you are defining the size and number of these tracks. Grid cells. This is the smallest unit of a grid, the intersection of a row track and a column track. Think of it like a single cell in a spreadsheet. Grid areas. These are named rectangular regions of the grid that span multiple grid cells. You can define a larger section of your layout, like a header area or a sidebar area, and then place content into these named areas, which makes your layout definitions remarkably clear and semantic. Now, let's look at the powerful properties you apply to the grid container to define its structure. Grid template columns. This is where you specify the number and size of your columns. You can use fixed units like pixels, px. Grid template columns. 200px 1fr1fr would create a 200 pixel wide first column and then two equally sized flexible columns that take up the remaining space. You can use percentages. Grid template columns, 20%, 80% for a two-column layout. The most exciting unit for grid is the FR unit, fractional unit. 1 FR means one fraction of the available space. If your container has grid template columns, 1 FR2, FR1 FR, it will create 3 columns. The middle column will be twice as wide as the first and third columns, and all of them will scale proportionally to fill the available width. This is incredibly powerful for creating flexible, responsive layouts without complex calculations. You can also use the repeat function to simplify repetitive tracks. Grid template columns, repeat 3, 1 FR, is a concise way to say, create 3 equally sized fractional columns. Grid template rows. This property defines the number and size of your rows, similar to grid template columns. You can use fixed heights, FR units, or auto, which lets the row size itself based on its content. For instance, grid template rows, auto 1 FR 100px, means the first row will be as tall as its content, the second row will take up all available vertical space, and the last row will be exactly 100 pixels tall. Grid template areas. This is perhaps the most visually intuitive way to lay out your grid. You define named areas within your grid using a kind of ASCII art syntax, and the browser then maps these names to your grid cells. For example, grid template areas. Header, header, header. Sidebar content, content, footer, footer, footer. This immediately creates a mental image, a 3-column wide header, a row with a sidebar and 2 content columns, and a 3-column wide footer. Each string in quotes represents a row, and the words within the string represent column cells in that row. Cells with the same name will merge to form a single grid area. A dot signifies an empty cell. This approach makes layout definitions incredibly readable and easy to modify. Gap, formerly grid gap. This property creates consistent spacing between your grid tracks, both rows and columns. You can specify a single value for both, gap, 20px, or separate values for rows and columns, gap, 10px, 20px. This is a huge convenience, as you no longer need to use complicated margins to create spacing between your grid items. Once you've defined your grid structure on the container, you need to place your content items into it. These properties are applied to the grid items: grid column start, grid column end, and grid column shorthand. These properties define where a grid item begins and ends along the column axis. You can refer to grid line numbers, e.g., grid column start, 1, grid column end, 3, or grid column 1/3, which occupies the space from line 1 to line 3, effectively spanning 2 columns. You can also use the span keyword, like grid column, span 2, which tells the item to span 2 column tracks from its starting position. Grid row start, grid row end, and grid row shorthand. These work identically to the column properties but horizontally, defining where an item begins and ends along the row axis. Grid area. If you've defined named grid template areas on your container, this is the simplest way to place an item. You simply give the grid item the name of the area it should occupy, e.g., grid area, header. The item will then automatically fill that entire named area. This provides a direct, semantic link between your structure and your content. An important concept is implicit versus explicit grid. When you define grid template columns and grid template rows, you are creating an explicit grid. But what happens if you place an item outside those defined lines, or if you have more grid items than your explicit grid accounts for? Grid will automatically create implicit tracks to accommodate them. These implicit tracks might have default sizes, often auto, but you can control them with properties like grid auto rows or grid auto columns. This allows grid to be flexible yet predictable. Finally, grid offers powerful alignment properties, similar to Flexbox, but adapted for 2 dimensions. Justify items on container. Controls how items are aligned along the inline, horizontal axis within their own grid cells. Align items on container. Controls how items are aligned along the block, vertical axis within their own grid cells. Common values for both: start, end, center, stretch, default. Justify content on container. controls how the entire grid is aligned along the inline horizontal axis within its container if it doesn't fill the entire width. Align content on container. Controls how the entire grid is aligned along the block vertical axis within its container if it doesn't fill the entire height. Common values for both. Start, end, center, space around, space between, space evenly, stretch. Let's put this into a verbal picture. Imagine you're designing the main layout for a blog. You have a div that will serve as your main page container. You set display. Grid on it. You decide on your overall structure. You want a header at the top, a main content area with a sidebar, and a footer at the bottom. You might define your columns first. Grid template columns. 200px1fr. This creates a fixed 200 pixel sidebar on the left and a flexible main content column that takes up the rest of the space. Then define your rows. Grid template rows. Auto 1fr auto. The auto rows for the header and footer will size themselves based on their content, and the 1fr in the middle will take up all remaining vertical space. Now, to make it truly semantic, you can use grid template areas. Header header, sidebar main, footer footer. This clearly states the layout. 2 columns for header, sidebar under header and main content next to it, and 2 columns for footer. Finally, you place your elements. Your header element literally gets grid area, header. Your aside element gets grid area, sidebar. Your main content element gets grid area, main. Your footer element gets grid area, footer. Instantly, you've established a clear, readable, and incredibly robust two-dimensional layout for your entire page. If you later decide to swap the sidebar to the right or add another column, you simply adjust your grid template area's definition, and the content will reflow into its new assigned regions. CSS Grid is a profoundly powerful tool that changes how we approach entire page layouts. It provides a level of control and expressiveness that was previously unthinkable with just CSS. In the next chapter, we'll delve deeper into mastering grid, exploring advanced placement techniques and how to use it for highly responsive and dynamic designs. 6. Mastering grid. Complex layouts and responsiveness. Having explored the fundamentals of CSS Grid, we now delve into its more intricate capabilities, allowing us to build truly dynamic, adaptable, and sophisticated layouts. This chapter will uncover advanced placement techniques, clarify powerful sizing functions, illustrate responsive transformations, and demonstrate how grid can be nested to create virtually limitless design possibilities. Advanced item placement with span. Recall that we can place grid items by specifying their starting and ending grid lines, e.g., from line 1 to line 3. A more flexible way to define an item's size is using the span keyword. When you tell an item to span a certain number of tracks, it will occupy that many columns or rows starting from its initial placement. Imagine a newspaper layout. You might have a main article that takes up 2 columns and a large, striking image within it that you want to stretch across 3 columns, even if the article itself only occupies 2. With span, you could define your overall grid, place your main article, and then tell the image element to grid column. Span 3. This means the image will automatically expand to fill 3 column tracks, seamlessly flowing across the boundaries of its parent article's 2 columns, creating a visually compelling layout effect. Similarly, an item could span multiple rows, perfect for tall sidebars or pull quotes that extend through several content sections. Dynamic grids with autofill, autofit, and min-max. One of Grid's most powerful features for creating truly flexible, quantity-independent layouts comes from combining repeat, min-max, autofill, and autofit. Min-max, minimum, maximum. This function allows you to define a size range for a grid track. For example, min-max 200px 1fr means a track, column, or row will be at least 200 pixels wide, but it can grow up to 1fr, 1 fraction of the available space, if there's more room. This prevents elements from getting too small on narrow screens, yet allows them to expand on wider ones. Repeat, autofill, min-max 200px 1fr. When used with autofill, Grid will create as many columns, or rows, as can fit with the specified minimum size, continuing to add empty tracks to fill the available space even if there are no items to place in them. Consider an empty photo gallery. Autofill would show you all the potential slots where photos could go, even if they're currently empty. It tries to fill the row with tracks, regardless of content. Repeat autofit min-max 200px 1fr. When used with autofit, Grid behaves similarly, but it will collapse any empty tracks. So, if you have only 3 items in a gallery that could theoretically hold 5, autofit will ensure those 3 items fill the entire width evenly, eliminating any empty slots. This is more common for content-driven grids, where you want the items to expand and perfectly fill the available space, collapsing any unused grid lines if there aren't enough items. It fits the items into the available space, effectively removing empty slots. Imagine a responsive product listing page. Instead of using media queries to meticulously define how many columns you need at each breakpoint, 3 columns on desktop, 2 on tablet, 1 on mobile, you can simply use grid template columns. Repeat autofit min-max 250px 1fr. This instructs Grid to make as many columns as will fit on the screen, each at least 250 pixels wide, and distribute any remaining space equally among them. Your product cards will automatically arrange themselves, wrapping to new rows and expanding to fill the width of their container, adapting perfectly to any screen size without you having to manage specific breakpoints for column counts. Responsive grid transformations. One of Grid's most profound abilities is the power to completely transform a page layout using media queries. Unlike Flexbox's one-dimensional adaptations, Grid allows you to redefine the entire two-dimensional structure. Consider a responsive dashboard layout. On a large desktop screen, you might define a grid with 3 distinct columns: a narrow column for navigation, a wide column for the main content display, and another narrow column for quick stats or notifications. You'd use grid template areas to precisely place a header across all 3, navigation in the first column, main content in the second, and stats in the third. As the screen shrinks to a tablet size, a media query can completely redefine the grid. You might change to a 2-column layout, perhaps stacking the quick stats below the main content. The header would still span both columns, but now the content and stats areas would occupy the second column, one on top of the other. All you're doing is changing your grid template columns and grid template areas definitions within the media query. On a mobile phone, another media query could collapse the entire layout into a single column. All elements header, navigation, main content, and stats would now stack vertically, ensuring optimal readability and ease of navigation on a small screen. This dramatic remapping based on named grid areas makes responsive design incredibly intuitive and maintainable. You're not just resizing items, you're literally redrawing the blueprint of your page for different contexts. Nesting grids. Just as a flex item can itself be a flex container, a grid item can also become a grid container. This concept of nesting layouts is incredibly powerful and is key to constructing visually rich and structurally sound interfaces. Imagine you're designing a complex article layout. The main article itself might be a grid item within a larger page grid, which defines the header, sidebars, footer. But inside that main article, you might want a precise layout for an author bio box, a gallery of images, or a multi-column text section. You would make the author bio div, which is already a grid item of the main page, its own inner grid container. Inside, you could define a small grid for the author's photo on the left and their name, bio, and social links on the right. This allows you to maintain perfect alignment and structure at every level of your design, creating modular, self-contained components. It's like building a city grid, and then within each city block, you design a smaller, detailed grid for a specific building, ensuring that even the internal rooms are perfectly aligned within their context. Layering and overlapping content. Grid's line-based placement system makes layering and overlapping elements remarkably straightforward. Because you can tell an element to start and end on specific grid lines, it's easy to place multiple elements in the same grid cells. For instance, you might have a hero section background image positioned to fill a certain grid area. Then, perhaps a heading and a call to action button are placed within the same grid area. By default, elements within the same grid cell will stack one after another. However, by using standard CSS position, absolute, on the overlaying elements relative to the grid item they are inside, or by making more explicit line-based placements, you can easily create sophisticated overlapping designs. You can then use the z-index property to control which element appears on top, creating depth and visual interest. This allows for effects like textual overlays on images, transparent panels floating above graphs, or visual elements that span across different layout regions, without resorting to complex negative margins or pixel-perfect positioning calculations. Mastering grid involves understanding how these powerful features work together. From dynamic item placement to complete responsive transformations, and the ability to nest grids for complex module design, Grid provides the most robust solution available for two-dimensional web layouts. With Flexbox handling the microalignments within components and Grid structuring the macro layout of the page, you have at your disposal a complete and highly efficient system for crafting any web experience. 7. Harmonizing Flexbox and Grid, hybrid layouts. By now, you have a solid understanding of both Flexbox and CSS Grid as standalone layout systems. You might even be asking, why do I need both? Can't one do the job of the other? This is a crucial question, and the answer unlocks the true power of modern CSS. Flexbox and Grid are not competing technologies, but rather complementary tools that, when used together effectively, allow you to build incredibly robust, flexible, and maintainable web layouts. The overarching principle to remember is the Grid for macro, Flexbox for micro rule. Grid for macro layouts. Grid excels at defining the overall page structure and managing the arrangement of major sections. Think of it as the architectural framework that defines the rooms, hallways, and load-bearing walls of your building. It's perfect for establishing the main regions of your website: header, main content area, sidebars, footer, and other large-scale divisions. Grid's two-dimensional control makes it ideal for handling complex responsiveness, allowing entire sections to reorder and resize across different screen sizes. Flexbox for micro layouts. Flexbox is the master of distributing and aligning items within a single dimension. Once Grid has defined the rooms, Flexbox becomes the interior designer, arranging the furniture and decor within those rooms. It's perfect for small groups of elements, such as navigation lists, buttons within a form, items in a product card, or content inside a sidebar widget. Flexbox solves specific alignment problems like vertical centering or distributing space among a finite number of items along one axis. Let's illustrate this synergy with common hybrid patterns. Page layout with component internal layout. This is perhaps the most common and powerful combination. Imagine building a typical blog or news website. Grid defines the page structure. You would likely use CSS Grid on your main page container, e.g., the body or a main div, to define the layout of the entire page. This grid might have clear areas for a header at the top, a sidebar on one side, main content in the center, and a footer at the bottom. Grid's Grid Template Areas property makes this definition incredibly intuitive and readable. Flexbox arranges content within those areas. Now, consider the components within those defined grid areas. Header. The header area, defined by Grid, might contain a logo, a navigation menu, and a search bar. You would make the header itself a Flex container. Now, Flexbox is your tool to arrange these elements horizontally with Justify content. Space between, perhaps to push the logo to one side and the menu search to the other, and vertically align items. Center, to keep them all aligned in the middle. Navigation menu. Even the navigation all inside the header can be another nested Flex container. This makes it trivial to distribute the individual list items, li, of your menu horizontally using Justify content or by applying gap between them. Sidebar content. Within the sidebar grid area, you might have a vertical list of categories or related articles. This list could be made a Flex container with Flex direction. Column, to control its vertical spacing and alignment. Product cards / article previews. If your main content area displays a collection of product cards or article previews, arranged by Grid as a responsive list, as we discussed in Chapter 6, then each individual card typically uses Flexbox internally. The card itself would be a Flex container with Flex direction. Column, To stack its image, title, description, and buy button, you might use justify content, space between, to push the button to the bottom of the card, ensuring a consistent visual baseline even if titles or descriptions vary in length. This pattern demonstrates Grid handling the major layout scaffolding, and Flexbox handling the internal arrangement of elements within specific components or content blocks. Each does what it does best: complex form layouts. Forms can be notoriously finicky to style, but Flexbox and Grid work beautifully together here. Grid for sections. If your form has different sections, e.g., personal information, shipping address, payment details, you can use Grid on the main form element to lay out these sections. Each section could be a grid cell, or you could create a multi-column grid with specific sections aligned vertically and horizontally. Flexbox for fields. Within each form section, for individual input fields and their labels, Flexbox is ideal. You can wrap each label input pair in a div and make that div a flex container. This allows you to easily align the label to the left or top of the input, control their spacing, and ensure consistent alignment across your form elements. Examples of synergistic solutions. Responsive dashboard. You might use a master grid to define the main layout of your dashboard, perhaps a fixed sidebar on the left, a main content area, and a smaller right sidebar. Within the main content area, you could have various dashboard widgets. Each widget could be a flex container, arranging its own internal elements, e.g., a chart, a title, a legend, efficiently. If you have a collection of small status cards within one dashboard panel, Grid might arrange these panels, but Flexbox will ensure those cards within the panel maintain consistent sizing and spacing. Header/footer. Beyond simple navigation, modern headers often contain many diverse elements: logo, main navigation, utility navigation, login, search, cart, language selectors, making the entire header element a flex container, which is itself usually a grid area, allows for easy distribution of these major sections. Then, each subsection, like the utility navigation div, can again be a flex container to arrange its own children. Content sections with dynamic items. Imagine a content section that needs to display 3 feature boxes side by side on desktop, but stack them vertically on mobile. While you could achieve this with pure Flexbox, by wrapping and changing direction, Grid might be used for the overall section layout, defining distinct areas for a main heading and these feature boxes. Then, the container for the feature boxes would be a flex container that arranges them. This separation of concerns can make the CSS clearer and more maintainable, especially as layouts become more complex. The key takeaway is that Flexbox and Grid solve different problems. Grid is about positioning things in relation to the page or a large area. It defines the major layout containers. Flexbox is about positioning things in relation to each other within a container. It handles the distribution and alignment of items inside those containers. By truly understanding when to apply each, you unlock the ability to build sophisticated, maintainable, and highly responsive web interfaces that gracefully adapt to any screen size and device, without the headaches and hacks of the past. The combined power allows you to structure your thought process. Sketch out your macro layout with Grid, then zoom in to micromanage the content within each area using Flexbox. This approach makes layout planning more intuitive and translates directly into cleaner, more robust code. 8. Beyond the basics, advanced CSS features. So far, we've explored the fundamental building blocks of modern CSS layout: the box model, measurement units, responsive design principles, and the powerful Flexbox and Grid systems. But the CSS landscape is constantly evolving, bringing with it an array of refined features that make web development even more efficient, flexible, and robust. These beyond the basics features streamline common tasks, enhance responsiveness, and open up new possibilities for dynamic styling. Let's dive into some of these advanced capabilities. The universal gap property. You've already encountered the gap property in the context of CSS Grid, where it neatly creates spacing between grid tracks. What's exciting is its evolution. The gap property and its individual components, row gap and column gap, is no longer exclusive to Grid. It now works seamlessly with Flexbox and even multi-column layouts. This is a major convenience. Previously, to create consistent spacing between flex items, you'd often have to apply margin right to all items except the last one, or use negative margins on the container. This technique quickly becomes cumbersome, especially when dealing with wrapping flex containers. With the universal gap property, you simply apply gap 20px or gap 10px 20px for vertical and horizontal gaps respectively to your flex container, and it automatically creates perfect, consistent spacing between all flex items. It eliminates edge case margin hacks and results in much cleaner, more readable CSS. Imagine a gift wrap where a magical spacing tool ensures every present is neatly spaced from its neighbor without you having to manually adjust each one. CSS functions for dynamic sizing. Responsive design is all about adaptability, and CSS now provides powerful functions that allow for truly fluid sizing based on calculations and conditions. Clamp, this function is a dream for responsive typography and fluid spacing. It allows you to clamp a value between a minimum and a maximum with a preferred value that scales dynamically. The syntax is clamp, minimum, preferred, maximum. For example, font size, clamp 1 rem 2 VW plus 1 rem 3 rem means the font size will never be smaller than 1 rem. It will never be larger than 3 rem. In between these two extremes, it will scale based on 2 VW plus 1 rem, 2% of the viewport width plus a base 1 rem. This ensures your text is always readable, never too small or too large, while smoothly adjusting with the browser window size. It's like a thermostat for your text size, ensuring it stays within a comfortable range while adapting to the ambient conditions. Min and max. These functions allow you to choose respectively the smaller or larger of a list of computed values. Width, max, 500px, 50%, means the element will be at least 500 pixels wide or 50% of its container's width, whichever is larger. This is useful if you want to ensure a minimum size, but allow an element to grow fluidly beyond that. Font size, min 2 rem 4 VW, might mean your font will scale with the viewport width, but will never exceed a maximum of 2 rem should the viewport become very wide. These functions bring powerful, if-then, logic directly into your CSS values. Aspect ratio property. Maintaining visual consistency is paramount, especially for media. The aspect ratio property allows you to maintain the intrinsic width-to-height ratio of an element, regardless of its content or its parent size. This property simplifies responsive images, videos, and custom components that need to preserve a specific proportion. Previously, achieving a perfect 16:9 or 1:1 aspect ratio for a responsive element, div, or iframe typically involved a hack using padding percentages on a parent element. Now, you can simply apply aspect ratio 16/9 or aspect ratio 1/1 to an element, and the browser will automatically calculate the necessary height or width to maintain that proportion as the other dimension changes. This is incredibly useful for responsive video players, embedded content, or building perfectly square card components that respond to varying screen sizes. Logical properties and values. Traditional CSS uses physical directions: margin left, padding top, border right. While intuitive for English speakers who read left to right, this becomes problematic in languages that read right to left, like Arabic or Hebrew, or vertically, like traditional Japanese. If you have margin left on an element, it will always apply to the left side, even in a right-to-left context where the start of the content flow is on the right. Logical properties introduce terminology that describes directions relative to the flow of content, not physical screen edges. Instead of margin left, you use margin inline start. In a left-to-right LTR language, this translates to margin left. In a right-to-left RTL language, it translates to margin right. Similarly, padding top becomes padding block start. Border bottom becomes border block end. These properties are critical for building truly internationalized and accessible websites that adapt not just to screen size, but also to user language and reading direction, ensuring consistent visual layouts for everyone. Container queries. This is arguably one of the most exciting and transformative advancements in recent CSS history. For years, responsive design relied primarily on media queries, which adapt layouts based on the viewport size, the size of the entire browser window. This works well for overall page layouts, but falls short for reusable components. A card component might appear in a wide sidebar on one page and within a narrow main content area on another. With media queries, the component would respond to the overall page width, not the specific width of its parent container. Container queries at container change this entirely. They allow an element to query the size of its parent container or even grandparent container and apply styles accordingly. Imagine a reusable product card component. With container queries, you can tell it, if my immediate container is less than 300 pixels wide, stack the image above the text. If my immediate container is wider than 300 pixels, arrange the image to the left of the text. This means component developers can build truly self-responsive modules that adapt to their context, regardless of where they are placed on the page or what the overall viewport size is. This makes components immensely more reusable and simplifies component-driven development. It's like a book changing its layout based on the size of its own page, not the size of the entire library. CSS variables, custom properties. While not strictly a layout feature, CSS variables, or custom properties, are foundational for building maintainable and scalable CSS, which directly impacts layout consistency. They allow you to define your own custom properties with values that can be reused throughout your style sheets. You declare a variable like this: primary color, 3498 dB, or spacing unit. 1 rem, you use it with the var function, background color, var primary color, or gap, var spacing unit. The benefits are immense: consistency, ensure consistent colors, spacing, and font sizes across your entire site. Maintainability, change a value in one place, the variable declaration, and it updates everywhere it's used. Theming, easily swap themes by changing a few variable values across your site. Dynamic changes, JavaScript can easily read and update CSS variables, allowing for runtime styling modifications that were previously much harder. These advanced CSS features collectively represent the ongoing evolution of the language. They empower developers to write cleaner, more efficient, and more adaptable code, providing granular control over layouts and improving the maintainability of complex web projects. While Flexbox and Grid provide the core layout structure, these beyond-the-basics tools refine that structure, making it more responsive, more accessible, and more dynamic than ever before. 9. Responsive design refined. Adaptability for every device. Responsive design isn't just about making your website shrink or expand to fit a screen. It's about providing an optimal, accessible, and enjoyable user experience across the myriad of devices and screen sizes available today. With the power of Flexbox, Grid, and the advanced CSS features we've discussed, we can now refine our approach to responsiveness, moving beyond simple breakpoints to craft truly fluid and adaptable layouts. Advanced media query features. While min-width and max-width are the workhorses of responsive design, modern media queries offer much more granular control. Combining conditions. You can combine multiple conditions using and, or, and not keywords. For instance, at media screen and min-width, 768px, and orientation. Landscape targets only screens wider than 768 pixels and held horizontally. This allows for highly specific layout adjustments. Range syntax. A more modern and readable way to write width-based queries is using range syntax. At media, width equals 600px is equivalent to at media, max width, 600px. Similarly, at media, width equals 768px replaces at media, min width, 768px. This cleaner syntax improves readability for complex conditions. Feature detection media queries. These queries allow you to adapt your design based on user preferences or device capabilities, fostering a more personalized and inclusive experience. At media, prefers color scheme. Dark. Apply dark theme styles if the user's operating system is set to dark mode. At media, prefers reduce motion. Reduce. Disable or reduce animations and transitions if the user prefers less motion, which is crucial for users with vestibular disorders or motion sickness. At Media, hover, and pointer. Fine. Apply different styles if the user has a precise pointing device, like a mouse, and supports hovering, allowing for richer interactive elements as opposed to touch-only devices. These advanced media query features move responsive design beyond merely adapting to screen dimensions to adapting to user intent and capability, leading to more thoughtful and empathetic user interfaces. Fluid typography and spacing. In Chapter 8, we introduced clamp, min, and max. These functions are central to achieving truly fluid typography and spacing, minimizing the reliance on arbitrary breakpoints. Instead of defining half a dozen different font sizes for a heading across various media queries, you can use a single clamp declaration like font size. Clamp I2 rem, 5 VW plus 1 rem, 4 rems. This ensures the heading scales smoothly, always staying within readable limits without jarring jumps at breakpoints. The same principle applies to spacing. Using rem units for margins, padding, and gaps provides a scalable foundation. By combining this with clamp or min/max. For key spacing values, you can create a truly fluid design where elements maintain their intended visual relationships regardless of the screen size, feeling organic and adaptive rather than merely reactive. Responsive images and media. Images and videos are often the heaviest part of a web page and require careful handling for responsiveness and performance. While not strictly CSS, elements like the HTML picture element and src set attribute, for images, are fundamental partners in responsive design. They allow the browser to pick the most appropriate image resolution or even a different image entirely based on screen size, device pixel ratio, and orientation. This means a mobile user gets a smaller, faster loading image, while a desktop user on a high-resolution display gets a crisp, detailed version, optimizing both bandwidth and visual quality. Within CSS, the object fit and object position properties are invaluable for controlling how images and videos fit within their defined containers. Object fit, cover, tells the media to fill its container while maintaining its aspect ratio, cropping if necessary. This is perfect for hero banners where you want the image to always cover the entire background area. Object fit, contain, ensures the entire media is visible within its container, even if it leaves empty space, letterboxing. Object fit, fill, stretches the media to fill the container without maintaining its aspect ratio, potentially distorting it. Object position allows you to control which part of the media is visible when it's cropped or contained, e.g., object position, top center. Together, these provide robust control over media presentation, ensuring your visual content always looks its best and performs efficiently. Viewport units for absolute responsiveness. We touched upon VW and VH earlier. These units are truly responsive as they are always relative to the viewport. VW is especially useful for elements that need to strictly maintain a proportion relative to the screen width, like a fixed-size header that should always occupy 10% of the screen's width. However, note that VW can sometimes be affected by scroll bars if they dynamically appear-disappear, causing a slight recalculation, which can lead to layout shifts. For most cases, though, they are a powerful tool for fluid scaling. Vmin and Vmax offer even more specialized use cases where you need an element to scale based on the smaller or larger dimension of the viewport, respectively. CH unit, character unit. While less commonly used for large-scale layouts, the CH unit is incredibly useful for text-heavy content. It represents the width of the 0 character of the element's current font. This might seem niche, but it's invaluable for setting optimal line lengths for readability. Typographic research suggests that an ideal line length for comfortable reading is around 45 to 75 characters. Using max width, 70 ch, on your paragraph elements ensures that your text never becomes too wide, regardless of screen size, significantly improving the reading experience. Accommodating different input methods. Responsive design isn't just about visual adaptation, it's also about usability across different interaction methods. Touch screens. On touch devices, tap targets need to be larger and more spaced out to prevent accidental touches. Standard guidelines suggest minimum tap target sizes of 48 x 48 CSS pixels and sufficient spacing between interactive elements. Mouse keyboard, users with a mouse benefit from hover states for additional information or visual feedback. Keyboard users rely on clear focus indicators, e.g., focus styles, to navigate interactive elements. Ensure that your responsive layouts maintain a logical tab order and that custom interactions are fully keyboard accessible. Accessibility in responsive design. Perhaps the most critical aspect of responsive design is ensuring that adaptability doesn't compromise accessibility. Source order versus visual order. We briefly touched on this with Flexbox's order property. It's vital that the visual presentation of your content, particularly interactive elements, aligns with its underlying source order in the HTML. Screen readers and keyboard navigation follow the source order, not the visual one. If your responsive layout reorders elements in a way that creates a confusing or illogical flow for these assistive technologies, e.g., a next button appears visually before a previous button, but comes after it in the HTML, it creates a significant accessibility barrier. Contrast and text size. Ensure that your fluid typography and color scheme maintain sufficient contrast ratios for readability across all screen sizes and user settings. Users with low vision may zoom in significantly, and your layout should not break or become unreadable when zoomed. Semantic HTML. As we'll discuss further, using appropriate semantic HTML elements, nav, main, button, for your content structure, rather than generic div elements, inherently improves accessibility. CSS then modifies the presentation, not the meaning. Responsive design, when refined with these advanced techniques and an unwavering focus on user experience and accessibility, transforms from a technical requirement into an art form. It's about designing a single, cohesive experience that gracefully molds itself not just to the device, but to the unique needs and preferences of every user, creating a truly inclusive and efficient Web 10. Accessibility and performance. Building inclusive and efficient layouts. Building beautiful and highly functional layouts with Flexbox and Grid is a significant achievement. But a truly great web experience extends beyond aesthetics and responsiveness. It must be accessible to everyone, regardless of their abilities or the technology they use, and it must load quickly and perform smoothly. This chapter delves into the crucial intersection of modern CSS layout with accessibility and performance. Accessibility A11Y. Layouts for everyone. Accessibility, often abbreviated as A11Y, because there are 11 letters between the A and the Y, is not an optional extra. It's a fundamental aspect of ethical and effective web development. When applied to layout, accessibility ensures that your users, whether they navigate with a mouse, keyboard, touch, or assistive technologies like screen readers, can understand and interact with your content effectively. Semantic HTML and its relationship to CSS. The most powerful tool for accessibility in web development is well-structured, semantic HTML. Elements like header, nav, main, aside, footer, button, and form convey meaning to browsers and assistive technologies. When you build your layout with Flexbox and Grid, always strive to use the most appropriate semantic HTML tags for your content. For instance, if you're creating a navigation menu, use a nav element containing an unordered list of items with a links, rather than just a series of div elements. Your CSS then merely presents this structure beautifully. The underlying meaning remains clear for everyone, including screen reader users. Visual order versus source order, the order property pitfall. In Chapter 3, we briefly touched on the order property in Flexbox, which allows you to visually reorder Flex items without changing their order in the HTML source code. This is a classic example of where layout capabilities can clash with accessibility. Imagine a form with fields that are visually rearranged with order to fit a complex layout. A sighted user might see first name, then last name, then email. However, if the HTML source order is email, then last name, then first name, a screen reader user or someone navigating with a keyboard alone will experience the form in the confusing, illogical source order. Best practice: Always strive to keep the visual order of elements consistent with their logical order in the HTML source. Only use order if you are absolutely certain that the new visual order makes perfect sense for all users, including those relying on assistive technology and keyboard navigation. Focus management and keyboard navigation. Ensure that all interactive elements in your layout, buttons, links, form inputs, are reachable and operable via keyboard. As users press the Tab key, a clear visual focus indicator, the default browser outline, or a custom focus style that maintains good contrast, should appear around the currently focused element. Modern CSS layouts should not interfere with this crucial aspect of navigation. Test your layouts simply by using the Tab key. If you get lost or can't reach an element, it's an accessibility barrier. Color contrast. The choices you make for text and background colors within your layout directly impact readability for users with low vision or color blindness. Sufficient contrast ensures that text is distinguishable from its background. Tools exist to check contrast ratios, e.g., Web Content Accessibility Guidelines specify minimum contrast ratios like 4.5, 1 for normal text. Dark mode features, at Media, prefers color scheme. Dark can help, but ensuring good contrast in both light and dark themes is vital. Responsive layout benefits for accessibility. Well-implemented responsive design naturally benefits many users with disabilities. For example, users with low vision often zoom in on web pages. A responsive layout, built with fluid units and Flexbox/Grid, will reflow smoothly when zoomed, ensuring content remains legible and navigable, rather than causing awkward horizontal scrolling. Similarly, a mobile-first approach often prioritizes clear, essential content, which benefits all users by reducing cognitive load. Respecting user preferences prefers reduced motion. As mentioned in Chapter 9, prefers reduced motion allows users to indicate they prefer minimal animation on web pages. For layouts that involve subtle transitions or animations, e.g., elements fading in or section reveals, ensure your CSS respects this preference, providing a stripped-down, static experience to avoid causing discomfort or sensory overload. Performance, efficient layout rendering. A beautiful layout is only effective if it loads quickly and performs smoothly, without jank or delays. Modern CSS, particularly Flexbox and Grid, are generally performant because they are natively implemented by browser engines. However, understanding a few principles can optimize your layouts further. Efficient CSS. While modern browsers are highly optimized, extremely bloated or inefficient CSS can still impact performance. Minimize file sizes by avoiding unnecessary selectors, duplicate rules, and overly complex nested structures that make the browser work harder to calculate styles. Leveraging CSS variables for consistency and minifying your style sheets for production are good practices. Layout thrashing, reflows, and repaints. Browsers work in stages. First, they calculate the layout where everything goes, then they paint it draw pixels on screen. Operations that force the browser to recalculate the layout repeatedly, layout thrashing, are performance killers. Historically, manipulating old layout models could easily trigger this. Modern CSS, especially Flexbox and Grid, are designed to be more efficient in managing layout changes. Minimize DOM changes. Fewer changes to the document object model, e.g., adding removing elements, changing sizes rapidly, reduce the browser's workload. Avoid forcing synchronous layout. JavaScript can sometimes trigger synchronous layout calculations by querying layout properties, like offset height, immediately after making changes. Batching changes or requesting values at appropriate times can mitigate this. CSS contain property. This powerful CSS property helps the browser optimize rendering significantly. By applying contain, layout, to a component, you're telling the browser that changes within this element will not affect the layout of elements outside of it. This allows the browser to perform layout calculations only for the contained element, rather than recalculating the entire page, leading to a performance boost. Other values like contain, size, or contain, style, offer even more specific optimizations. Responsive images and media, revisited. As highlighted earlier, images and videos constitute a large portion of page weight. Ensuring you serve appropriately sized and optimized images via HTML's SRC set and picture, and not just resizing huge images with CSS, is critical for performance. CSS object fit and object position then ensure these optimized images display well within their responsive containers. You also wouldn't want a full hero video preloading on a mobile phone if the user is on a metered connection. Font loading strategies. Web fonts are crucial for design, but they can cause performance issues if not handled correctly. Large font files can delay text rendering, leading to a flash of unstyled text or flash of invisible text. Strategies like font display. Swap, ensure text remains visible even if the custom font hasn't loaded yet, swapping to it once available. Preloading critical fonts can also improve performance. Hardware acceleration. Certain CSS properties, particularly transform, opacity, and filters, can often be offloaded to the graphics processing unit, GPU, for rendering, resulting in smoother animations and transitions, while layout properties are primarily CPU-bound. Understanding how browsers optimize these visual properties can contribute to a snappier user experience. In conclusion, a mastery of modern CSS layout goes hand in hand with a commitment to accessibility and performance. These are not separate concerns, but interwoven aspects of creating a truly world-class web presence. Building layouts that are inclusive and efficient ensures that your content reaches the widest possible audience, providing a seamless and enjoyable experience for everyone, everywhere. 11. Real-world applications and best practices. Having navigated the depths of Flexbox and Grid and explored the advanced features that complement them, we're now ready to apply this knowledge to the real world. Modern CSS isn't just about understanding properties. It's about using these powerful tools to efficiently build common design patterns, structure your style sheets for maintainability, and effectively troubleshoot when things don't quite go as planned. Common design patterns with modern CSS. Flexbox and Grid effortlessly tackle many layout challenges that were previously complex or required hacky solutions. Dashboard layouts. Imagine an administrative dashboard or a web application interface. These often feature a fixed sidebar for navigation, a main content area for data, and perhaps a smaller panel for notifications or quick statistics. How to build? You would typically use CSS Grid to establish the overall page structure. For example, a main grid might define 2 or 3 columns, a fixed-width column for the sidebar, and 1 or 2 flexible columns for the main content and any auxiliary panels. Grid's grid template areas are perfect here, allowing you to visually map out sidebar, main, and stats regions. Within panels, inside each of those grid-defined areas, e.g., the main content panel, you'd likely use Flexbox to organize the individual widgets or components. A dashboard widget might be a Flex container itself, using Flex direction, column, to stack a title, a chart, and a legend, or justify content to distribute elements within a footer. Media objects. A classic design pattern involves an image or icon positioned next to a block of descriptive text, which should ideally wrap gracefully on smaller screens. How to build? This is a perfect job for Flexbox. Make the container of your image and text a Flex container. The image and the text block become Flex items. By default, they will align horizontally. On smaller screens, a media query can change the Flex container's Flex direction to column, causing the image to neatly stack above the text. This pattern ensures clear visual association and responsive flow, whether you're displaying user comments, product features, or an article byline. Sticky header footer. Many websites feature a header at the top and a footer at the bottom that always cling to the top and bottom of the viewport, respectively, even if the content between them is very short. How to build? You can make your body element or a full-page container div a Flex container with display, Flex and Flex direction, column. Then give your main content area, the one between the header and footer, Flex 1. This tells the main content to grow and take up all available space, effectively pushing the footer to the bottom of the viewport. This is a simple, elegant solution for a common design requirement. Overlay modal windows. Centering dynamic content, like a pop-up modal or a login form that appears over the main content, used to be deceptively difficult. How to build. This is where Flexbox shines. Make the container for your modal, which might take up the entire screen, a flex container. Apply justify content. Center and align items. Center to it, and your modal content will perfectly center itself both horizontally and vertically, regardless of its size or the screen dimensions. Responsive pricing tables. A common challenge is displaying multiple columns of pricing plans or features, which then need to stack vertically on mobile. How to build. The container for your pricing plan columns can be a flex container with FlexWrap. Wrap. Each individual pricing column is a flex item. On large screens, they will naturally arrange horizontally. As the screen narrows, the FlexWrap property will cause them to neatly wrap onto new lines, effectively stacking them in a single column or two-column layout as space dictates. Inside each pricing column, Flexbox can again be used to stack the features and buttons. Complex card styles. While the card collection itself might be arranged by grid for overall layout, the individual card's internal structure, e.g., an image, a title, a description, and a button is often best handled by Flexbox. How to build. The card wrapper should be a flex container with flex direction. Column. This stacks the card elements. You might use flex 1 on the text content to make it stretch and push the button to the bottom, ensuring uniform card heights even with varying text lengths. Component-based CSS. These design patterns highlight a philosophical shift in how we approach web development. Component-based CSS. Instead of thinking about styling entire pages, we now think in terms of small, self-contained, reusable building blocks called components, e.g., a button component, a card component, a navigation component. Flexbox and Grid are perfectly suited for this. Each component can manage its own internal layout using these systems, independent of its context. You build a button that centers its icon and text with Flexbox, and that button will look and behave correctly whether it's in a header, a form, or a side panel. This modular approach makes code more maintainable, easier to scale, and promotes consistency across large projects. It's like building with standardized Lego bricks. You focus on making each brick perfect, and then you can combine them in countless ways to build larger structures. CSS methodologies. To keep component-based CSS organized and maintainable, especially in team environments, various methodologies have emerged. BEM, Block Element Modifier. This is a popular naming convention that provides a clear, highly structured way to name your CSS classes. For example, you might have a card, the block, a card image, an element within the block, and a card dark, a modifier that changes the block's appearance. While it might look verbose, this system makes it immediately clear what a class does, prevents naming conflicts, and increases predictability. It's like giving every part of your Lego model a consistent, descriptive label. Utility-first CSS. This approach focuses on creating a large set of single-purpose utility classes, e.g., D, Flex for display. Flex, M4 for margin, 1rem, text center for text align, center. Instead of writing custom CSS for every component, you compose layouts by applying these existing utility classes directly in your HTML. Frameworks like Tailwind CSS popularize this approach. The benefit is rapid prototyping and high consistency, as you're always using predefined atomic styles. It's like having a toolbox full of very specialized, perfectly tuned wrenches, each designed for one precise task, allowing you to quickly assemble rather than custom fabricate. Regardless of the methodology, the underlying power of Flexbox and Grid remains the same. They are the versatile tools that these methodologies manipulate and organize. Maintaining and scaling CSS. As projects grow, managing CSS can become complex. Leveraging modern features and practices is key. CSS variables, custom properties. Re-emphasize their importance for centralizing design tokens. Define your core colors, spacing units, font sizes, and breakpoints as variables. This makes global changes simple, e.g., adjust primary color in one line and your entire site updates, and reinforces design consistency. Preprocessing tools. While this book focuses on plain CSS, tools like SAS or LESS are often used in larger projects. They allow you to use features not yet native to CSS, such as nested rules, mix-ins, reusable blocks of styles, and logical operations, which can help organize and streamline your code before it compiles into standard CSS. Debugging modern CSS. Even with the best planning, layouts rarely come out perfectly on the first try. Mastering your browser's developer tools is indispensable for debugging Flexbox and grid layouts. Browser developer tools. All modern browsers, Chrome, Firefox, Edge, Safari, offer sophisticated dev tools. Flexbox Inspector. When you select an element that is a Flex container in the Elements or Inspector panel, you'll often see a small Flex icon next to it. Clicking this will reveal a visual overlay on your page showing the Flex axes, the Flex items, and how space is being distributed. You can often toggle properties directly in the dev tools and see the changes live, helping you understand why items aren't aligning as expected. Grid Inspector. Similar to Flexbox, selecting a grid container will often show a grid icon. Clicking it displays the grid lines, track numbers, and even outlines of named grid template areas directly on your page. This X-ray vision highlights exactly where each grid item is placed, which lines it spans, and where your empty cells or implicit tracks might be. This visualization is invaluable for diagnosing complex grid alignment issues. These visual debugging tools are your closest companions. If a Flex item isn't growing as expected, or a grid item is appearing in the wrong cell, the dev tools can give you immediate, visual feedback on the underlying Flexbox or grid calculations, allowing you to quickly identify and fix issues. By combining the power of Flexbox and grid with smart component design, robust methodologies, and efficient debugging techniques, you're not just building web pages. You're crafting scalable, maintainable, and highly performant web experiences suitable for any real-world application. 12. The future of web layout. What's next? As we reach the conclusion of our journey through modern CSS layout with Flexbox and grid, it's vital to acknowledge that the web is a constantly evolving landscape. CSS is a living language, perpetually enhanced by the collective efforts of browser vendors, the CSS Working Group, which defines the standards, and the developer community. While Flexbox and grid represent monumental leaps in layout capabilities, the innovation doesn't stop here. New features are continually being proposed, developed, and implemented, further empowering designers and developers to create increasingly sophisticated, responsive, and maintainable web experiences. Understanding this dynamic nature of CSS is key to staying at the forefront of web development. The principles you've learned in this book around context, responsiveness, and separation of concerns will remain relevant, but the tools to achieve them will continue to grow and refine. Let's preview some of the exciting developments and emerging features that are shaping the next generation of web layout. Subgrid, the missing piece for deep alignment. One of the most anticipated and now increasingly pervasive features is subgrid. To understand its significance, recall that a grid item can be a nested grid container. However, prior to subgrid, this nested grid was entirely independent. Its lines did not align with its parent's grid lines. This meant if you had a complex layout where a contained component needed to align perfectly with the lines of its grandparent grid, it was largely impossible or required very complex calculations. Subgrid solves this. When you declare grid template columns, subgrid, or grid template rows, subgrid, on a nested grid container, it tells that nested grid to inherit and use the track sizing from its parent grid. This is a game changer for deeply aligned layouts, perfectly suited for components that need to stretch and align across an already defined parent grid structure. Imagine building a calendar component where the days of the week need to align perfectly with a larger month grid, or a complex data table where internal cells need to line up with the main table columns. Subgrid finally provides the elegant solution for this multi-level alignment, eliminating the need for hacky workarounds and ensuring pixel-perfect harmony. This feature is now widely supported across modern browsers and is becoming an essential tool for sophisticated design systems. CSS nesting, preprocessor simplicity, native power. For years, developers have relied on preprocessors like Sass to write nested CSS rules. allowing them to scope styles within parent selectors for better organization and readability. This made for cleaner, more modular stylesheets. With CSS nesting, this capability is becoming native to CSS itself. You'll be able to write styles like this using the and symbol to refer to the parent selector, similar to Sass. Card styles, background color, var card BG, and title styles, font size 1.5 rem, and hover state for card. Box shadow, 0 px4 px8 px RGBA, 0000.1. This significantly improves the readability, maintainability, and modularity of your stylesheets by keeping related styles grouped together, just as your HTML elements are grouped. It streamlines the development process directly within the browser's understanding of CSS, potentially reducing the need for build steps involving preprocessors for simpler projects. This feature is gaining rapid browser support. Cascade layers at layer, mastering specificity wars. The CSS cascade can be mystifying, especially when dealing with conflicting styles and specificity. Understanding which rule wins can be a source of frustration, often leading to hacky solutions or overusing important. Cascade layers, introduced with the @layer @rule, provide a revolutionary way to organize your stylesheets and control the cascade explicitly. You can define distinct layers and arrange them in an intended order. At layer base, components, utilities, overrides. At layer base, /global reset, basic typography, body font family, sans serif. At layer components, /component specific styles, button padding, 10px 20px. At layer utilities, /utility classes, e.g., for spacing or text alignment, M0 margin, 0. At layer overrides, /high priority fixes or user preferences, special text color, red. Styles from later layers always override styles from earlier layers, regardless of their specificity. This gives developers granular control over the cascade, making it much easier to manage large stylesheets, integrate third-party libraries, and prevent specificity wars, where you endlessly increase specificity just to override a previous rule. This feature, already well supported, provides a powerful new tool for managing CSS complexity and ensuring predictability in your styles. Scroll-driven animations, interactivity reimagined. While not strictly a layout structure feature, scroll-driven animations significantly enhance the interactivity and visual appeal of layouts. This emerging capability allows parts of your CSS animations to be controlled directly by the scroll position of an element or the entire page. Imagine elements that fade in as you scroll, images that parallax, navigation bars that shrink, or progress bars that fill up as you move down a section. Previously, such effects typically required complex JavaScript. With scroll-driven animations, these intricate and visually engaging interactions can be defined directly in CSS, leveraging the browser's native performance optimizations. This opens new avenues for creating immersive and dynamic user experiences without adding JavaScript overhead, allowing the layout itself to tell more of a story. The importance of continuous learning. The rapid evolution of CSS highlights a critical message. The journey of learning web development is never complete. The specific syntax and properties may change, but the core principles you've absorbed throughout this book, thinking about responsiveness, considering device capabilities, structuring content semantically, and focusing on user experience, will remain foundational. To stay current and explore these exciting new frontiers, Mozilla Developer Network, MDN, WebDocs. This is the definitive resource for web technologies, providing comprehensive and up-to-date documentation. Industry blogs and newsletters. Follow reputable web development blogs like CSStrix, Smashing Magazine, A List Apart, and newsletters that cover new CSS features and best practices. Experimentation. The best way to learn is by doing. Play with new features, build small prototypes, and push the boundaries of what you think is possible. Final thoughts. The transformation of web layout over the past decade. From reliance on hacky tables and floats to the precise and powerful systems of Flexbox and Grid, is nothing short of revolutionary. These tools have democratized complex design, allowing developers to craft responsive, accessible, and high-performing interfaces with unprecedented ease. You now possess a comprehensive understanding of these foundational systems, along with the advanced techniques that allow for truly fluid and intelligent designs. You can confidently build layouts that adapt to any screen, cater to diverse user needs, and are poised to embrace the innovations yet to come. Go forth and craft beautiful, resilient, and inclusive web experiences. The canvas is yours, and with modern CSS, your creative possibilities are truly limitless.